Hey guys, I know that it's hard to be quarantined, but we're going to get through this. Uh, every day that you're out, I will post a video kind of explaining what your assignment is for the day. And then I just ask that if you have any questions, email me. We can jump into a Zoom or whatever you might need to do to kind of help you understand what we're doing. So if you are in second hour, you've probably already done most of this. Second hour is ahead of all my other classes. So just watch the video and then complete whatever you have not done. Third, sixth, and seventh hour, this you will need to do for today. So here is our agenda. We are going to talk about modeling light, and then there's an exit ticket, and then we're going to watch Bill Nye just to give us a little break. We've been working super hard, and I think everybody kind of deserves a little brain break today. So our learning target that we're working on is I can model how light is reflected or transmitted through a material. And today we're going to focus on that modeling part. How do we show it in our drawings that light has been reflected and transmitted? So just reviewing some definitions here. Reflect means that light is bouncing off of an object, and transmit means that light is traveling through that object. Here is some data from our lab, from our light collection lab. This is my data, so it's going to be slightly different than yours. And again, we're not so concerned about the exact numbers here. We're just looking for patterns. So the glass, we can see that if we look at these two numbers, this is much bigger. So most of that light went through or was transmitted through the glass. Some light was reflected back, and that's why we can see a reflection sometimes in glass. The one-way mirror, it's about half and half. About half the light went through, about half the light was reflected, which is why when we look at a one-way mirror, some people can see through the one-way mirror. That would mean the light was transmitted, and other people see the reflection in the one-way mirror, which means the light was reflected. For a regular mirror, we saw that no light or very little light was transmitted or went through it, and almost all the light was reflected off. Okay, so if we look at our data, here is a number line that I showed yesterday in class. We can see that the one-way mirror kind of is in the middle, with about half the light being transmitted through and about half the light being reflected. Glass, on the other hand, very little light reflected, most transmitted, and mirror, very little transmitted and most reflected. The reason I showed this number line is because when we look at it, we can see, like, look at our one-way mirror is like both a mirror. It's kind of like the middle of a mirror and a glass. It's like in between both of them. It acts kind of 50-50 as a mirror and 50-50 as a piece of glass. So what did we figure out? Well, we figured out that a one-way mirror reflects and transmits light, and about half of that light is reflected and about half of that light is transmitted. Tomorrow we're going to learn how a one-way mirror is constructed, what it's made of, and why this actually happens. But today I just want us to focus most on the modeling. So this was our target, right? I can model how light is reflected or transmitted through a material. We're pretty good at understanding which material out of the three reflect light or transmit light. Today we're going to focus on how to model that. So we filled this out yesterday. Remember, we're using these dashes to kind of show the amount of light. With the glass, it transmits most light and reflects a little. So we have the light coming in, and then we have the light that's being transmitted, most of the light, with a little light being reflected. And we're using our key over here to make that happen. With a mirror, it reflects all light. So we're using the all light arrow and just pointing it backwards as a reflection. And then with a one-way mirror, it does both. Oh, this should be blue. Sorry, this line right here should be blue for the reflecting. But it's reflecting some and transmitting some. So we use this key here to kind of show how much of the light is doing what. So what we're going to be doing in class today is class is going to be practicing making up some models. And I'm just going to show you the models so that you can understand them. So in this scenario, you're meeting your best friend downtown. You're walking and you look up at the buildings and you notice that you can see the reflection of the sky and the other buildings here in the building. Just then, your best friend, your BFF, runs out of the building because they're so excited to see you because they could see you from inside. What I want you guys to do is work on modeling the path of light that causes both the reflection and your best friend's ability to see you through the window. Go ahead and pause this and just try to do that on a scrap sheet of paper. And then when you're done, come back and push play. So here's my model. It's a simple model, but here's my model. So I'm doing the building reflection, not the sky. I could have made this a cloud. But here's my light source, because we always have to have a light source. And then I'm pointing my light in straight lines. It's hitting the building. It's reflecting, bouncing off of the building, and hitting, this is the glass on the other building. Once it hits that glass, it's going to do two things. Some of the light is going to be reflected, and some of the light is going to pass through or be transmitted. So here's the light that's reflected back to my eyes. So this red path shows how come the building is reflected in the other building or in the windows. This light comes here, bounces off the building, goes to the windows, and then bounces off the windows and directly into my eye, which allows me to see the reflection. At the same point, while some of that light is being reflected, some is being transmitted through. And the light that's being transmitted through allows my best friend who's in the building to see outside. So the person who's in the building can see this building because the light comes here, it bounces off, and goes straight directly into the eye. The purple line here is how come my best friend can see me. She's inside, I'm outside. So why does she see me? Well, I have the light coming from the sun, the source, hitting me, going directly to the window. And from the window, it's going to do two things. It's going to transmit through some that allows my best friend to see me, and some of it's going to be reflected back that allows me to see my reflection. All right, let's try another one. Scenario number 2. Someone stole Miss McLaughlin's Diet Coke. I am addicted to it, so true. You were a witness to the crime. You saw a person sneak into her room and run out with her Diet Coke. You didn't know who it was, so Miss McLaughlin set up a lineup for you to identify the culprit. But to protect your identity, she's using a one-way mirror. Model the path of light that causes this phenomenon. All right, pause here. Try to make a model of that, and then I'll show you mine. Here is mine. I have my Diet Coke, possible Diet Coke thieves here. A one-way mirror is this green line, and then I'm right here. So how does this one-way mirror work? Well, there has to be a light on the inside, or on one side, and that light is shining directly onto the two culprits, or the two suspects of the Diet Coke thievery. That light hits the person, bounces off, and then hits the one-way mirror. From the one-way mirror, some of that light is transmitted through, and some of it is reflected back. The reflection back allows him to see himself, and the transmission through allows me to see him. The purple line, same thing. We're coming down, hitting the person directly. That light bounces off, hits the one-way mirror. And from there, two things are happening. Some light is reflected back, which allows this person to see themselves. And some light is transmitted through, which allows Miss McLaughlin to see them. All right, so the rest of the kids in class are doing an exit ticket right now. I've put the exit ticket in the Schoology folder today, so if you want to look at it and see if if it's something you'd be able to do, you're welcome to. That is not a required assignment, but you're welcome to go look at that. What we're going to do next, after the kids have done the exit ticket, is we're going to go back to our initial models that we drew of Pete and the teacher in his music lesson with the one-way mirror. And we're going to revise this model. We're going to make it better because look, we just have two lines here. But we're going, and some of these, like this is the path of sight, not the path of light. We're going to go back through and spend a few minutes revising it. Tomorrow's lesson, I will post a picture of how we revised it and kind of talked about why we did it the way we did. All right, if you are in 6th or 7th hour, you are going to see a link to a science pretest. You need to complete that pretest today. It's very complicated, and it is completely okay to write an answer, I don't know. That is an acceptable answer. Attempt to answer it. It is a pretest. You are not supposed to know how to do this yet, and I just need to see who knows how and who doesn't before I teach it. So there is no expectation that you will be able to do this. It is not a graded assignment. I just need you to try. And again, I don't know is a totally acceptable answer if you really don't know how to do it. So 6th and 7th hour, make sure you open up the science pretest in Schoology and complete that. 2nd and 3rd, you did this a few weeks ago, so you don't need to do this. And then here's what we're going to do for the rest of the hour. The kids are going to watch Bill Nye, a Bill Nye Light video, which is really, really good in talking about transmission and reflection. I will post a link in Schoology if you would like to watch it. If you don't, it's okay. It's not required, but if you'd like to, it is out there. All right, you guys, I'm so sorry that you have to be quarantined, but we're keeping each other safe and I appreciate it. So reach out if you need anything and I will talk to you tomorrow. Bye.